Hello, good morning. All of you are fine. In the last class, we discussed about the definition of the relations and the basic concepts of relations and types of relations. Okay. So today we will discuss some questions of the NCERT textbook, exercise 1.1. Let's related to relations. Let's see the questions. What are the questions? First questions. Question number 1. Question number 1 is what determine whether the following relations are reflexive, symmetric and transitive. A relation is given. A relation is given and we have to determine whether the relation is reflexive, symmetric and transitive. For that, the basic concept we need, when the relation is reflexive, when the relation is symmetric and when the relation is transitive. So what is given relation? R, number 1, R is equal to what? X comma y, such that the condition is what? 3x minus y is equal to 0. This is the relation on the set what? On the set A, on A is equal to what? 1, 2, 3 up to 14. The condition, what is the condition? That condition, what is the relation? If we see the pictograph, if we make it a diagram, so relation from A to A, and this element is x, this element is y. This is the relation. So 1, 2, 3, 4, 5. In this 14, it will come 14. Here also 1, 2, 3, 4 up to 14. Now condition is what? 3x minus y. That means what? 3x is equal to y is equal to 3x, y is equal to 3x. And if we write the tabular form of the relations, what do we get? Y equal to 3x means if x is equal to 1 or y is equal to what? 3. So 1 comma 3, we get 1 comma 3. Then if we take x is equal to 2, y is equal to 6, 2 comma 6, then we will get 3 comma 9, then 4 comma 12. Next if we take 5, 3 5 is 15, 15 is not there, so up to this much. These are the elements of the relations. 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. Okay, now we have to check whether this relation is reflexive or symmetric or transitive. We have to check it. Reflexive. In case of reflexive, what we have to see, the elements of A, these elements should be each and every element. That is, one must be related to 1. That means what? 1 comma 1 belongs to R. 2 comma 2 belongs to R. That type of element should be belongs to R, belongs to the relations. So if we take 1, is it 1 comma 1 belongs to R? No. Since we can write this one, since 1 belongs to A, but 1 comma 1 does not belongs to R. It does not belongs to R. So R is not reflexive. We can write directly this way. R is not reflexive. Okay, symmetric. We can take any example from the relations, any element of the relations. Since 1 comma 3 belongs to R, 1 comma 3 belongs to R. In the symmetric, what was the symmetric? Symmetric is that, what is the symmetric? If A comma B belongs to R, if A comma B belongs to R, and it implies that B comma A belongs to R, then we can say the relation is symmetric. So 1 comma 3 belongs to R. Is it 3 comma 1 belongs to R? No. It does not imply that 3 comma 1 does not belongs to R. So R is not symmetric. R is not, yeah, how do you write? R is not symmetric. R is not symmetric. Next one is transitive. Let's see transitive. That we have to check, each and every one we have to check. Check the elements that A comma B and B comma C, that should be last elements of the first and the first element of the second should be same. So 1 comma 3, you can take 1 comma 3, 3 comma 9, these two elements. Here 1 comma 3 belongs to R and 3 comma 9 belongs to R. So 1 comma 3, A comma B and B comma C, is it? But if we take 1 3 3 omit the 3 3 1 comma 9 we'll get 1 comma 9. Is it belongs to R? No, this does not belongs to R. A comma B belongs to R, B comma C belongs to R, but A comma C does not belongs to R, so R is not transitive. R is not transitive. So in this way you have to determine whether given relation is a reflexive, symmetric or transitive. This is the number 1. See the next number. Number 2, what is given? The set. What is the set? The relation is what? Number 2 relation is R is equal to what? What is given? X comma Y such that Y is equal to X plus 5. X is less than 4. And XY belongs to N. The relation is on natural number. Relation is on natural number. That is X comma Y should belongs to N. So same way, if we see the diagram, what will get? See. This is N. This is also N. Natural numbers start from 1 to infinite. Okay. But X is less than 4. This is X. This is Y. X is less than 4. So 1, 2, 3. Will not take more. And Y is also natural number 1, 2, 3, 4, 5. In this way it will come. Now see what will be the elements of the relation. R is equal to, if we write in the table of form, what will get? When X is equal to 1, X relation is what? Y is equal to X plus 5. If we put X is equal to 1, Y is equal to what? 1 plus 5 is 6. So 1 comma 6. If we to put X is equal to 2, then what will get? 2 comma 7, then 3 comma 8. 1 comma 6, 2 comma 7, 3 comma 8. Okay? And nothing. Same way, what will write? Reflexive. We have to check the reflexive. So what are the elements? X is 1, 2, 3. Is it 1 comma 1 belongs to 1 belongs to N, but 1 comma 1 does not belongs to R. So R is not reflexive. We'll write R is not reflexive. Symmetric. What will write symmetric? 1 comma 6 belongs to R, but 6 comma 1 does not belongs to R. So R is not symmetric. Okay? And last one, you have to check this transitivity. Transitivity. How will check the transitivity? Let's see. The elements should be like that: A comma B, B comma C, A comma B, B comma C. That type of elements we should need. Transitivity. Here what are the elements? 1 comma 6, 2 comma 7, 3 comma 8. 1 comma 6, 2 comma 7, 3 comma 8. So if we take 1 comma 6, 1 comma 6, there is no other elements related to 6. Again, if we take 2 comma 7, we will not get any elements related to 7. If we take 3 comma 8, we will not get any element related to 8. There is no element related to 8. Okay, so we will not get any elements related to the 8, which make this transitivity is contradiction. Okay, which makes the contradiction of the condition of transitivity. That means what? This is the relation is transitive. So what we can say here? Here we can say, let x comma y belongs to R. For all x comma y belongs to N, x is less than 4. Here we will not get any element related to y which contradicts the conditions of transitivity. Therefore, the relation is transitive. Therefore, the relation is transitive. Okay. So this we have to check whether it is clear. This is reflexive. This is not reflexive. This is not symmetric, but it is the relation is transitive. Next question. What is the next question? R. So interesting question. This is an interesting question. R is equal to what? X comma y such that x is the father. X is the father of y. X is the father of y. Reflexive. Is it reflexive? Reflexive means what? X is the father of x. Then x comma x belongs to R. Will you get x is the father of x? No, never. No way. X is not the father of x. So x comma x does not belongs to R. Okay. So it is not reflexive. Then x is father of y. Symmetric. What will you say symmetric? X is father of y. Is it y is father of x? If x is father of y, is it possible that y is father of x? Never. So it is not symmetric. Next is x, y, z. We will take x, y, z. X is the father of y. X is father of y. Y is father of z. X is father of y. Y is father of z. What is the relation between x and z? Then x is the grandfather of z. X is not father of z. So it is neither reflexive nor symmetric nor transitive. Okay. So this way we have to solve it. Next one is what? Question number 2. What is the relation? R is what? A comma b such that a is less than b square. A is less than b square is neither reflexive nor symmetric nor transitive. We have to check. Where a comma b belongs to the real number. Reflexive. Let's say reflexive. Let 1 comma 2 belongs to R. We can take half. Half belongs to R. Half is a real number. But what you can say? 1 by 2 and 1 by 2 whole square. 1 by 2 whole square is what? 1 by 4. Is it 1 by 2 is less than 1 by 4? Never. But 1 by 2 is never less than 1 by 2 square. So what you can say? 1 by 2 comma 1 by 2 does not belongs to R. It doesn't belongs to the relation. So R is not reflexive. Symmetric. Any two elements you can check. If we take 1 and 2 comma belongs to R, such that 1 comma 2 belongs to R. That means what? That is 1 is less than 2 square. 1 is less than 2 square. It is true. But 2 is never ever less than 1 square. That is what? 2 comma 1 does not belongs to R. So what you can say? R is not symmetric. R is not symmetric. Okay. These two real numbers and under the condition a comma b belongs to R, it implies that b comma a does not belongs to R. So R is not symmetric. R is not reflexive. R is not symmetric. And last we have to check R is not transitive. For that, how many elements you have to choose? 3 elements. That is, this examples you can take yourself. That is your choice. Whatever I am taking, you can. It is not compulsory that only you have to choose. You can choose another examples also. Transitivity. How to check transitive? 3 numbers. Suppose 1 minus 3 2 belongs to R. 1 minus 3 2 belongs to R. Okay, let's see. 2 comma minus 3 belongs to R, and minus 3 comma 1 belongs to R. That means what? 2 is less than minus 3 whole square, minus 3 is less than 1 square. Okay, but two is never ever less than 1 square. A comma B belongs to R, B comma C belongs to R, but B comma A comma C never belongs to R. That means what? 2 comma 1 does not belongs to R. 2 comma 1 does not belongs to R. Therefore R is not transitive. Okay, so this relation is neither reflexive nor symmetric, not transitive. Next, question number 8 of textbook question C. What is given text question number 8? Show that the relation R is what? Set A is given. What is the set? 1, 2, 3, 4, 5. This is the set. And relation is, what is the relation? R A comma B such that modulus of A minus B is an even. This relation, we have to show that this relation is an equivalence relation. That means it is reflexive, it is symmetric, it is transitive. So for this first reflexive, say reflexive. Here we can take the half of the letters. For all A comma A belongs to A. This A belongs to A. Condition is a modulus A minus B is an even. Even means what? That must be divisible by 2. These are the elements. All the elements are represented by a small a, which belongs to A. For all A comma A, modulus of A minus A is equal to what? Which is 0. A minus A is 0. Is it divisible by 2? Which is divisible by 2. That is what we can say. A minus A is an even. It implies A comma A belongs to R. So R is reflexive. Next is symmetric. For A comma B belongs to A, let A comma B, the elements belongs to this relation. Okay, elements belongs to this relation. If the elements belongs to the relation, then what is the condition? Modulus of A minus B is an even. Implies modulus of A minus B is an even. If a modulus of A minus B is an even, what we can say? If modulus of A minus B is an even, let me see the example. 3 minus 5 is even. So what will be modulus of 5 minus 3? 3 minus 5 is minus 2, modulus of minus 2 is 2, it is an even. What is the modulus of 5 minus 3? 5 minus 3 is also 2, it is an even. So what we can say? B minus A, modulus of B minus A is also an even. That means what? What we can say? B comma A belongs to R. Therefore R is symmetric. We assume that A comma B belongs to R and we are getting B comma A belongs to R. So R is symmetric. First we are getting reflexive, second we are getting symmetric. Next we have to check whether it is transitive or not. Let's see transitivity. How many elements you have to choose? 3 elements. A comma B comma C belongs to A, capital A in this side. For all A comma B belongs to, say, let A comma B belongs to R and B comma C belongs to R. A comma B belongs to R means what? Modulus of A minus B is an even. Here modulus of B minus C is an even. Okay, if it is an even, that is multiple of A minus B is multiple of 2. So what you can say? Modulus of A minus B is equal to 2k. K is an integer. Modulus of B minus C is equal to This is K1 we can take, this is K2. Where K1 and K2 are some integers. That is what we can say. If we remove the modulus, what will get? If we remove the modulus, then A minus B is equal to plus minus 2K1. Here what will get? B minus C is equal to plus minus 2K2. Then if we add both these things, now A minus B plus B minus C, what will get? Plus minus 2K1 plus minus 2K2. This plus B minus B cancel, A minus C, plus minus we can common, 2 is common, K1 plus K2. Okay? Then if we remove the plus minus, what will get? Modulus of A minus C is equal to what? 2 into K1 plus K2. That is multiple of 2. That is what we can say. A comma C is an even. Therefore R is transitive. So we are getting R is reflexive, R is symmetric, as well as R is transitive. Therefore R is an equivalence relation. R is an equivalence relation. So in this way you have to solve the problem with the help of the concepts of the relations. I hope you all understand. In the next class we will discuss more questions. Thank you. Have a nice day.